Hello, everyone. This is exciting. It's our first time doing a stream like this. So I'm Al. You probably know me from, I don't know, the internet somewhere. I'm probably the one who pestered you about joining here somehow. And next to me, nope, here. This is Peter. Peter works with me at Tilt, and Peter's going to be our co-host.
Hi, Al.
Hello. Do you want to say a few words about yourself? You look very funny, Peter.
Oh, because I'm hearing audio in two sources.
Yeah, you should mute your browser and just keep the call audio going. By the way, if everyone can hear both of us, could you please leave a comment so we know that everything's working? And speaking of comments, there you go, we have comments. Okay, we had a technical difficulty and Peter has left the meeting. All right. Just a second, everyone, sorry. Right, so right now I'm telling Peter to join the call again because computers, yeah, computers. So while that's going on, let me come here to the comments and see what everyone's saying. So apparently people can hear us and that's great. Oh, I think Peter is back on. Peter, mute YouTube and just leave our call open. Okay. Now, back to the big screen. Would you care to introduce yourself, Peter?
Yep, I'm Peter. I've now set up my browser correctly, and I run customer success at Tilt.
There you go. So Peter's going to be watching the comments. So whenever you have things to say, he's going to read me and stop my live coding to say, hey, this person asked this question. What's the donation goal for writing the operator in COBOL? That is a good question, Dan. So Dan, let me put the comments back. So Dan Miller, who just said that, he works with us at Tilts too, and he's being a very funny person, like he always is. But yeah, we can do this in COBOL. Maybe not today, because I think most people are expecting Go. All right, so I'm going to start. I'd very much like for this to be a conversation, not a lecture. So it's not like a talk, it's more like a chat between friends. So please do leave comments if something doesn't make sense, if you don't understand anything, or if you're just curious or anything you'd like to ask. And then we're gonna have a chat while this happens so that we can make this fun and interactive and not boring, because I was not a fan of school and I think you were not either. So I can't see my comments anymore. Now I'm looking at my terminal. So I'm going to share my screen if I can find the button. There, now we have my screen on the screen, hopefully. Do I need a frame so you can see? Okay, this is better, right? Okay, so we're gonna do it like this and yeah. So, to get started, Peter, do you know what a Kubernetes operator is?
Definitely not.
Okay, you know what Kubernetes is?
Yep.
Okay, good. So let's just start with the operators. So operators are basically when you have when you're using Kubernetes, Kubernetes monitors. It has like a control loop where it monitors all the resources you have, like your pods, your deployments, all of that kind of stuff. And the thing is, it works great for those things that are already a part of Kubernetes. If you need to monitor something new, something else, something that's unique to your system, you're going to have to create an operator. So you create a custom resource. So here our resource is going to be called machine, and I'm going to explain why in a second. So there's a pod, a replica set, all the Kubernetes things. Now we're going to have a machine, which is something we create with the parameters we want. And in addition to that, in addition to the resource, we also create a controller for the resource. So whenever any change happens to that resource we created, Kubernetes is going to do to that resource what we tell it to do, basically. That's an operator. So it's a way to extend Kubernetes so that you can use it beyond what's done out of the box for your own stuff in your own system. Does that make sense? Okay, so when you decide to write a Kubernetes operator and you read pages like what I have on the screen here right now, it's going to tell you to, one operator per application. We're going to break this rule because you see, but anyway. And then there's other good advice like use declarative, English is hard, use declarative APIs, whatever that means. Compartmentalize features via multiple controllers. There's a bunch of good advice here. And there's also use an SDK like Qbuilder. So that's what we're going to do. So this is Qbuilder. It's a great project. It does lots of things for you, so you don't have to do them by hand. So you could write a ton of YAML by yourself, but if you use Qbuilder, you don't have to, which is great. And big shout out to Solly, who's one of the maintainers. And Solly helped me a lot when I was just learning this. So big thanks there. And here's what we're going to do. So we're going to make a useless machine using Kubernetes operators. So if you don't know what a useless machine is, you're about to learn. So a useless machine is a machine that does this. There you go. You turn the machine on, it turns itself off. That's it. Super fun, right? You turn it on, it turns itself off. Now, this one's kind of boring because it doesn't do anything fancy, but if you look at something like this, you press the button, it waits a little bit, then it presses back. Sometimes it's really fast, sometimes it makes you wait and it just plays around with you. So that's a useless machine. Peter, if you send me messages on Slack, everyone can see them.
Oh, great.
Is it lagging behind on YouTube?
Yeah.
Yeah, YouTube is always like 20 seconds behind or something, so that's fine. And yeah, it's a bit laggy in general, but I think we will manage. So anyway, we're going to create this silly useless machine using Kubernetes operators. So we can create an object and then Kubernetes deletes it. And we're going to use, there's also two things I wanted to show you. One is, this is a stream by dev.x. It's a new resource we're creating where we're going to share a bunch of cool things about developer experience in the realm of containers and Kubernetes. So if you want to be notified whenever new content is out, put your email here. We're not going to sell it to spammers. Also, you can just subscribe on YouTube, and there's that. And so besides Qbuilder, we're also going to use Tilt. So Tilt is a tool that watches your project, your code, for changes. And whenever you make a change to your code, it live updates your code into Kubernetes. So your code is running on Kubernetes. Every time you make a change, it gets live updated. And so basically we don't have to build a new image, push the image, kubectl to apply, all of that stuff every time. We just write our code and Tilt takes care of everything for us. We can talk about the setup of Tilt later if y'all are interested in that. But anyway, I'm going to get started. I'm going to go to my terminal here. And let's just see if there are any comments. And then I'll start writing the code. So
I got one for you, El.
Yeah.
Walid Lazar asks, do you have an opinion regarding Qbuilder versus the operator framework SDK?
Yeah, to be honest, I don't, because when I did the research, I just thought, oh, well, Qbuilder looks more fun. And then I decided to use that. I never used the other one. I heard things about it. I never used it. So the things that I have heard is that the people I talk to prefer Qbuilder. It's more friendly or something like that. But I cannot really say that it is so. I just heard it. So that's what I can tell you. Anyway, I'm going to move on and put the code very big on the screen now. So Peter, I'm sorry you won't be visible for now, but feel free to speak. You're still on the audio. There you go. Okay, so I'm going to create a new directory here. It's going to be called, I don't know, Dex. And to start Qbuilder, how's the size? Is the size good? If someone complains, let me know. All right, so to start Qbuilder, first I need to init. So I'm going to do Qbuilder init, and this is going to create a ton of YAML for me, so I don't have to write all that YAML myself. So if I look at the files that I just created, it's more YAML than I can shake a stick at. But all this YAML doesn't do anything by itself. For it to do something, we need either the resource or the operator. So let's create those. And I'm going to do Qbuilder create, and I'm going to create a resource and not an operator. Since I'm going to use both, I'm just going to create both right now. So this time I already have a resource. I'm just going to create the controller. Okay, now if we check the files again, we can see that we have machine types here, and the name of the resource I created is machine, so that's why it's called machine. And we also have a machine controller, and we're going to go into those in detail in a moment. But first I wanted to show you something that is very specific to Qbuilder, which is interesting. So here I'm going to, let me see if it already created all the files. So list config crd basis. No, it's not here, so we're going to need to create that. So make generate, I think I need to use first, and then make manifests. Okay, now I can do config crd basis, okay, and this is the definition of our crd. So now I have a YAML that shows me, okay, it's a custom resource, Qbuilder something something, it's called machine, plural machines, and it has all the description here. And then there's a field, like the spec has a field called foo, and we're going to change this in a minute. And basically, yeah, this is where, like, if this were a pod, this is where you would put the image, so those kinds of properties. So this is cool. So let's put one of these machines that we created onto Kubernetes and see how that works. How do I do that? I forgot. How do I do it again? Oh, right. So I'm going to do make install right now. Actually, let me show you something. If I do kubectl get machine right now, I'm going to get nothing because our server doesn't know what a machine is. Now I'm going to do make install. It's going to put that stuff on the cluster, this CRD that I just showed you. And now if I do kubectl get machine, well, now the error is different. It's not that it doesn't know that resource type, it's just that there are no actual machines running. So let's change that. I'm going to do kubectl apply a file, and Qbuilder generates a sample file for me. So let's see how that works. It's going to be in config samples and something. Yes. Okay, now kubectl get machine. Okay, so I do have a machine now. It's called machine sample, which is the sample that Qbuilder created. And basically now Kubernetes knows that there's this resource called machine, and we didn't specify yet the fields we wanted to have, the properties we wanted to have, or how this is displayed on the screen, but there's already a thing there called machines. So that's cool. My camera is a bit dark. Can I make it lighter? Apparently not. Okay. Now I want to change, first of all, I want to change the way that this is shown, because name and age doesn't matter to me. I want some custom fields there. And there's a really cool thing, and this is the Qbuilder documentation. There's a really cool thing you can do, which is to add additional printer columns. And this is, I think it's a relatively new feature for Qbuilder, but let's look at that in practice. So I'm going to create a new window here for me. So here, and let's just leave that there. And here I'm going to open Vim. And we're going to look at machine types. And this is the definition of our CRD. So yeah, these are the fields that are going to be used to generate the CRD. So for example, object meta is where you have the name of the object and the namespace. Machine spec is where you have the options like that foo field that we saw. Machine status is basically the status fields and so on. And there's something interesting here. And it's this Qbuilder object root equal true. So we have some directives with the plus Qbuilder that we can add. And I'm going to add that one that I copied from the website. So I can type foo here and foo here. And now let me come here to this other window, and we can do make manifests again. And now if we look at the CRD that was created, it's going to have those different fields. So where is it? Config CRD basis something. If we scroll all the way up to the top, additional printer columns, spec.foo. So what's that going to do? So now when I do kubectl get, it shows me the fields that I want and not the default ones. And we're going to use this a bunch as we go. Now let's come back here. To create our useless machine, I don't want this foo field. I want a machine type field because some machines are useless and some are not. So machine type. Here as well, machine type. And I'm just going to copy this, and I want a status field. And I'm just going to call it status. There we go. And okay, so I'm going to save this. I'm going to delete the machine we already have.
Ooh, El, we've got a question for you.
Yeah, let me switch to the comments. Wow, we have lots of comments. Hello, everyone. Okay. Oh, look, Jefferson is here. Hi, Jefferson. And Atomizer says, is Qbuilder's annotation some kind of standardized Go code generator or a custom system? I don't know if there's a standard to these directives. I had never seen something exactly like this before. So maybe it's special to Qbuilder, maybe not. But either way, to use it, you're going to need to go to the Qbuilder documentation anyway, so that you know what are the things you can do. So whether it is a Go standard or a custom system, you're going to have to go to their documentation anyway. But yeah, I had never seen something quite like this before, so maybe it's a custom system. I hope that answers your question. If it didn't, please ask more. Now, let's get back to the code. Okay, I'm going to delete the machine I already have because I want to create a different one. So now I'm here and I can go to, actually, wait a minute, no, get out of here. I'm going to go to config, samples, and I'm going to rename this to useful, because we're going to start with a useless machine. Sorry, we're going to start with a useful machine. We're not going to get to useless machines right away. All right, so let me refresh this, useful. Okay, so the name of this machine is going to be machine useful, and we don't have a foo field anymore. We have a machine type field, and this is going to be useful. Okay, now let's go back there. And what did I want to do? Yes, I wanted to change the print columns. So one is going to be machine type, and that is spec.machine type. The other is going to be status, and this is going to be status dot status. So I just need to copy one more thing because I'm using a status sub-resource, so I'm going to need this there as well. There you go. And now this should work. So I'm going to come back here. I'm going to do, well, first let me, okay, I'm going to do make manifests again. And we can check this by, what is the file called? Tilt something, yes. Now you can see that my additional printer columns are machine type and status on the CRD definition, exactly like we wanted. Now if I do make install, and then I need to run the new machine that I created. So kubectl apply file, where is it? Config, samples, and useful. Okay, now if we do kubectl get machine, we have our useful machine. On the screen, we have the machine type and the status. So our print columns are working. We have the resource type that we wanted. So that's all cool. That's great. We basically have half the equation finished. But the thing is that the other half takes a lot more work. So let's get to the other half. Here, now we need to do something with the controller. Because the thing is, if you only have the resource and you don't have a controller for it, it's not going to do anything. So there's no point to it. So let's take a look at the controller. So the controller is somewhat simple at first, but here's where you add your logic. So there's this method called reconcile. So reconcile, it's basically that thing, you know how, let's see if Peter knows this. Let's give Peter a trick question. Hey Peter, how you doing?
Great.
Do you know what a declarative system is? Hint, that's what's Kubernetes.
Yeah, definitely.
Yeah? Yeah, I'm totally putting you on the spot, man.
I know, and I love it. A declarative system. I don't know, Al. Give me a hint. Give me a hint.
So,
it's where all configuration is. No, you tell me.
Declared?
It's declared? Is that?
No.
Yeah, something like that.
No, it's not.
No.
No, a declarative system is where you tell Kubernetes, I want the state of things to be like this. So you don't tell it how to get there. You just tell it, this is what I want. You figure it out.
What's the opposite of a declarative system?
It's, I think they call it imperative. So the traditional way is you tell the system, do this, do that, and then you achieve your goal. The declarative system, you tell the system, achieve that, I don't care how, and then the system is in charge of getting there. So that's what that process of making something get to the state, the ideal state that you declared, that is called the reconciliation, and there's a reconciliation loop for that. So let's get back to the code so I can show you that. So this is a reconciler loop. So basically, I think I can hear a slight echo of myself. That's strange. Do you have anything playing there, Peter? If you do, just try to mute it. Well, okay, then it's just...
You sound totally fine over here, Al.
Yeah? Okay, it's just the internet being weird. All right. Reconciler loop. Let me remember where I was going with this. Yes. For example, if you declare that you want 100 replicas of a pod, one pod dies, and then the pod controller is going to see, oh, wait, there's something missing here, and it's going to fix that. So that process is called the reconciliation. And that's what this method does. So here I'm setting something up where I'm saying that this type is going to be watching for updates, deletions, and creations on machine resources. And whenever a machine resource goes through any of those changes, this method's going to be called, and then things are going to be reconciled. Now, how things are going to be reconciled, that's what your code's going to do. Kubernetes can get this to run whenever it has to, but what's going to happen is what you write here. So let's write some code here and see what happens. I'm going to create a log variable here, and let's just do log.info hello from machine controller. Cool. And let's put some metadata here as well. Okay, so in theory, whenever I create or modify or delete a machine, I'm going to get this message from my controller. But of course, we need to do something first. We need to run the controller. And this is where I'm going to show you tilt. So usually you would do something like this. You do make run, and then it's going to compile that and run the process, and the process is going to connect to your kubeconfig, through your kubeconfig to whatever cluster you're using. So hello from machine controller, because there is a machine there and it detected that the machine exists. It ran the reconciliation loop, successfully reconciled because we did not return an error. So, okay, there's a machine, hello from the machine controller, everything is fine. Basically, that's what's happening here. The problem is if I run this on my terminal, I have to manually come here and end the process and run it again whenever I make a change. And that's annoying. And also this is running on my machine. This is not running on Kubernetes. And whenever I'm developing for Kubernetes, I'd rather run things straight inside the cluster and not have to worry about putting it inside the cluster later and then things don't work anymore. So we're going to start tilt right now. And for that, I'm going to need to copy my tilt config file. And I have this from a separate time that I did this project. And if you are interested, then we can talk about how I configured tilt for Qbuilder later. But let me show you how it works first. So I'm going to copy from my useless machine project my tilt file. And I'm going to do the same to my Docker file that I created specially for this, that we can then live reload our code into. So let me just check something. This is not what I wanted. Okay. Now I'm going to do tilt up, and tilt's going to start. And it's going to open up a dashboard here. And if I get my face out of the way, where's my face? Here. I don't have a face anymore. Oh no. So when you're running an application with a bunch of separate microservices, this is where they go. So it's a list. Here it's only one microservice, and this is my controller. And you can see these are the same logs that we had before. So hello from machine controller, successfully reconciled, same as we saw before. And I also have some special functions here. So for example, whenever I change my code, this recompile function is going to run and it's going to put things, it's going to update things inside the cluster. If I change my CRD definition, this is going to run and it's going to update things. So that machine type field, if I decide to change it for, I don't know, machine category, this is going to run and update things automatically, so we don't have to do it by hand. I'm going to put my face back now. Okay, so let's have some fun with this machine controller and see everything that it can do. And in this first part of the talk, I'd like to basically show you all the operations that you can do with Qbuilder on your Kubernetes operator. So let's look at that. Okay, so here we receive a request and we're not doing anything with the request. We're just saying hello, but we actually do want to do something with the request. And what we're receiving here is a control.request object. And all this gives me is the name and the namespace of the object that suffered some change. It doesn't give me the object itself, so I don't know the properties of the object. I just know the name of the object. So the first thing I need to do if I want to do anything here is to use the name to actually get a copy of the object so I can read it and modify it. So let's do that first. I'm going to need a context. If you're a Go programmer, you know what it is. If you're not, then it doesn't really matter. And when it's relevant, you're going to stumble upon this and then you can Google it. All right, so here's the code. I'm going to get the resource and I'm going to need that context. I'm going to need the name and the namespace of the object, and I'm going to need a blank machine to put that stuff on. Now, do we have a blank machine? We do not, so let's create one. var machine, it's going to be this one. And this one is basically what we created on the CRD. So let me show you again. So remember this file where we put the machine type field and all of that. So this, we're basically making an empty variable of this type. And that's what this is. I'm going to put this up here. So now I'm going to take the resource with the name of the request I received. I'm going to ask the API for all the information about that, and I'm going to put this in the empty variable that we created. So if there's an error to this get attempt, then I'm going to complain. I'm gonna put a log message here that's going to be, let's see, oh no, couldn't get resource. And I'm going to return an error as well. So here, instead of returning nothing in the error field, I'm gonna say I'm gonna return the error. But I want to wrap this up into this first, and I'm gonna explain why in a minute. Though I suspect a few of you are gonna figure this out, are gonna have figured this out by the time I get there. All right, Pierre is yawning right now. You can't see it, but I saw it. Look. I caught him. Anyway, back to the code. So assuming I did this correctly and that now my machine object contains actual information, now I can do things like if machine.status.status is empty. And by the way, if you watch the talks from Solly, the maintainer of Qbuilder, something that you're going to learn is that you should not rely on the status of things because it's ephemeral, it changes. We're doing it here basically just to play around, but you're gonna have to brush up on best practices before you start doing this stuff in production. So a lot of what we're doing here is more educational than what you should do in production, but you're gonna learn the basics anyway. All right, so if the machine status is empty, I want the machine status to be instead howdy. And now I need to apply that status change. So I'm going to do request status update, and I give it a context, and I give it a pointer to my variable where I made the change. And once again, we do the same error handling. So I'm just going to copy it from above. There you go, but instead of couldn't get resource, it's going to be, oh no, couldn't update status. Okay, now let's see if this runs. So Tilt has already picked it up, recompiled, updated my, what's it called again? My controller. So let's do something here. Qbuilder, get machine, and watch. Let me open this up a little bit. So you can see that the status is howdy, and it did not start off as howdy, it became howdy because of our controller. So let me get another window here so we can see that. So I'm gonna go back here to go source dex, Qbuilder, delete machine all, and now I'm gonna create it again, and you're gonna see the status change. Qbuilder, apply file, config, samples, and useful. So you can see that it started with an empty status field because we did not define it anywhere. And then it was changed to howdy because we told the code to do that. So cool. We know that we can interact with code. We know that we can interact with resources from the codes that we're writing here. Oh, my picture is on top of the, that's annoying. Let me fix this. Give me a second. Tmux magic here. Forgot the command to switch panes on Tmux. If anyone knows it, let me know. So now let's just do that again. Qbuilder, delete machine, and then create it again. So you can see that the status was empty, and then we changed it. Right. Let me now do something a little bit more fun, because we want to play with useless machines, not useful machines. And so far we only have a useful machine. So let's do something that's going to decide for us if something is useful or not. So we can create a machine type variable. We can call it machine.spec.machine type. And then we can switch on this variable. And if the machine is useful, we're going to do something. If the machine is useless, we're going to do something else. Hey, Peter, do you have any comments? Okay.
Nope.
Nope. All right. So here we can do, okay, so if the machine is useful, I'm just going to say machine.status.status is going to be okay, because we don't care about useful machines. But if the machine is useless, the status is going to change to delete. Right. Now, let's do something here. So we need to apply the status that we just changed here. And then we're going to filter it up top before we get to this point and say, okay, if the machine.status.status, if the status is okay, wait, there you go. If the status is okay, we're just gonna quit, no big deal, everything is fine. Let's just get this empty return message and put it there. And if the status is delete, we're gonna need a different, something different. But let's do this one step at a time. So for now, let's just pretend that this is okay too. So Tilt has picked up my changes and it's going to update my controller. All right. So now you can see that my useful machine, it was first blank, then it changed to howdy, and then we detected that it is a useful machine and we changed it to okay. Now let's create a useless machine and see if it changes to delete. So config samples. I'm going to copy this into a useless machine. And let me change here, so it's going to be useless. And the machine type, more importantly, is going to be useless. So let's come back here. And here, kubectl, apply, file, useless. Now, okay, this changed the status from okay to howdy to delete. So now let's change this code and make it actually delete. So let me take a sip first. Because, you know, speaking apparatus is a bit dry. All right. So how do we do this? We can once again use the same structure, but now we can do r.delete. We give it a context and the object that is to be deleted. Same as before. If there's an error, then I'm just going to copy the same thing we did before. And here, could not delete object if there's an error. But here, if it does manage to delete things, then I'm going to be snarky. Useless machine deleted. Okay. So Tilt's going to run that for me. Okay. You can see another delete here. And useless machine deleted. But we can also see something interesting. Oh no, couldn't get resource. So where does that come from? And oh no, couldn't get resource comes from the first one where I get a resource. It comes with a name here. So basically Kubernetes is telling me, hey, something happened to a thing called machine useless. And then I try to get machine useless and it's not there. So what's happening? The reconciler is called whenever a resource is created, modified, or deleted. So when it's deleted, I still get a request, and that you can use for cleanup tasks and stuff like that. The point is, that's why I'm ignoring not found errors. Oh shit, I just screwed it up. Okay. That's why I'm ignoring not found errors, because what you saw here is basically just a message, but it was successfully reconciled. If I had returned the error, it would basically crash the whole thing, and Kubernetes would try to do the exponential backoff, retries, and all of that. And what I'm doing here is I'm just saying, okay, it's fine. Resources get deleted. It's okay. We don't need to keep retrying to do it. So just so we know, and then we get the log message that the resource wasn't there, which is here. But then we don't get like a bunch of mess on the Kubernetes side. Okay, now we have a tiny problem here, moving on. And the problem is, let me stop this and start this again. And let me come back here. So I can create a resource like kubectl apply file useless. I can create a machine. And if it's a useless machine, Kubernetes is going to delete it. If I create it again, Kubernetes deletes it again. If I create it again, Kubernetes deletes it again. And the problem is that basically we already achieved this objective. So this is done. And we now need to move on to the more fun bit, which is this one, the machine that kind of makes fun of you. So let me do that. Now, I created here a bunch of stuff, and this is just Go. There's nothing Kubernetes here, so I'm not going to live code it or explain it because it takes too long. But you're going to see the results, and it's kind of interesting. So I'm going to need a new type of machine. It's going to be called Playful, and this is the machine that's going to be Playful. And what it's going to do is this, which you don't know what that does yet. And I'm going to copy another bit of things here. Once again, and I'm just gonna make this a tiny bit pretty. I'm gonna save this, and I don't think you know what it does yet because it's a surprise. So is this working? Yeah, it's working. So
we got a question coming in.
Okay, let me move on to questions. Comments. Let's see. Lots of talk. I'm gonna have to scroll back and reread all of this. Thanks for the comment, Glauco. AJ says, are you talking about the imperative? Yes, that's what I was talking about. This was a few minutes ago.
No, scroll down.
Yeah. Anderson, can't believe I missed the starting of the live stream. Anyway, I'll keep watching. Yep, and this is going to be recorded, and you can always watch it on the channel again. Linux tips. Yay, another fan. And Valid, I don't know how to pronounce your name. I did my best, sorry. When you change the code of your app, does Tilt Live reload the state of the container without rebuilding it? It does some sort of sync or something. Yes, that's exactly what it does. So it's going to... Okay, let me show you this trickery because it's interesting. Let me get back here to this. Okay, so let's open here. So this is my container. It basically has nothing in it except for a manager, and the manager is the executable inside my operator. It's the executable that runs my operator. The actual operator is this manager binary. If I go to my tilt file, and if you never used tilt before, this might be a bit hard to understand. But I have a Docker build with restart. So I'm using that Docker file, and I have a live update directive where basically whenever... Okay, so let me start from the beginning. So I have a local resource called recompile that is watching my controllers folder. And whenever I make a change to my controllers folder, it generates a bunch of stuff again. It recompiles my binary again, and it just puts the binary in my local file system. So I'm recompiling locally on my machine. So this Docker build it restarts. This is a built-in function on Tilt. It's going to watch that binary. It's going to watch just that file. Whenever this file changes, it's going to reload this file inside the container. Now, sorry, my camera got tired. Something interesting is that it has this with restart function, and this is kind of new on Tilt. And what that does is it basically uses enter. So this is a cool article about it. Let me show you the website, enter's website. Okay, it uses enter, and this is a command that watches when files change. So we take that Docker file that I showed you, we wrap it around with this function here, and basically Tilt's going to create a new image with enter in it, and that enter is going to be watching my binary inside, wait a second, inside this Docker image. Long story short, because this is getting too complicated, whenever I change my code, Tilt recompiles it, and then it calls this function. It syncs the binary with the, it refreshes the binary inside the container, so it puts the new one in place, and then it restarts the container using enter. So enter restarts the process, and basically it looks like nothing happened. Everything keeps running as usual. Everything is automatic. Everything is in the background. You don't notice anything, but actually every time I change my code, it's basically instantly gets run inside Kubernetes. Okay, that was a big detour. Let's come back to our controller. If you have more questions about it, also, what was your name again? Walid. Yes. If you have more questions about this process, feel free to ask, and we can loop back to it once I'm done with the demo. All right, back to the code. Oh, okay, we just created the playful stuff. Cool, I forgot what I was doing. So let me come back here to the Tilt dashboard. Apparently everything is running. Now I just need a playful machine so I can show you what this does. So I'm gonna create a playful machine. So first I wanna change how this is displayed. I wanna do this a bit differently. So I'm gonna do watch, kubectl get machine, just because it looks a bit better for what we're gonna do. Okay, and here I'm going to do copy one of these into playful.yaml. Cool. Now I need to edit that. Playful, no, I need to refresh. Okay, so this is going to be playful, and this is going to be playful. All right. Now, a very important technical detail. As you can tell, there is a little finger looking thingy, and it goes towards the lever looking thingy. That's important. Okay, so let's run this. Kubectl apply file playful, and now we have, if you look at this part, those little balls, the O letters there, let's assume they're a finger looking thing going and coming back and playing with you as it goes towards the lever looking thing. And when it reaches the lever, it deletes itself. And you should see Peter's surprise face. So there you go. It went there and it came back, and it went there again and it came back. So it was kind of messing with you, and then it touched the lever and deleted itself. So let's run it again, because this is extremely silly, but I find it super cool. What do you think, Peter? Isn't this one of the greatest achievements of computer science?
This is the most impressive thing you've done all week, Al.
That's fair. Okay, so this time it's taking a while. Well, we're just gonna have to wait. There you go, deleted itself. Cool. So let's see what y'all are saying. I want a lot of cheering and applause. That's awesome. Oh, yes. Oh, but he was saying that's awesome to the other thing. So Naomi is the only one cheering this. Thanks a bunch, Naomi. You know how much I love you. We're going to be friends forever. All right, let's come back to the code. I want to show you all one more thing. So here, by the way, we can go back here and read all of the status updates. So like every time the little finger went up by a character or down, I got a hello from machine controller. At the end, it deleted itself, useless machine deleted, and that was a success. And that was a successful reconcile. Yay! And then oh no's, it couldn't get the object because it was deleted. So everything running as usual. Now, one thing that's interesting here, and I'm going to explain this to Peter because else it's just weird. So here's the thing. When you have a machine controller, it is watching objects of the type machine. But let's say I have an object and I want this object to watch objects of a different type. So let's say I want my machine to watch my pods or something like that. Can we do that? Can we do that? What do you think, Peter? Can we?
No, it's too hard.
Wow, it is very hard. Luckily, you have me here, so I'm going to do it anyway. And something else is, what if we need to create a machine? So, well, not a machine, but a resource. Can I use, for example, my special Qt controller to create a pod or create a deployment? No, we can't? Okay,
Definitely not.
Luckily I'm here, so I'm going to show you how to do it. So, when I originally created this material, my thought was, oh, I can put those status updates on the internet, so I'm going to create a web controller. And then it's going to have a built-in web server, and then people can connect to it and see the status updates live on the browser. So that was a great idea, but of course that's a lot of work. And I mean, we don't need to do all of that stuff, right? It's not relevant to the concept. So I'm just going to create a web resource and a web controller, and neither of them are going to do anything. They're just going to sit there, but we're going to pretend that that's where our web server is, and that web resource is going to interact with our machine resources. So let's do that. Now, something important. There is the right way to have multiple controllers within the same Qbuilder project. So there is a right way, and then there's the way that I'm going to do. It's wrong, it's hacky, but it works. And I mean, we're not doing rocket surgery anyway, so in my opinion, it's fine. So I'm just going to use that to show you a few extra operations, but you should know that if you are using multiple controllers in the same Qbuilder project, go read the docs and do it the right way. But I don't want to go that far into detail, so I'm just going to do it the wrong way. Peter, does that make sense?
Yep. I think you're saying you're going to take some shortcuts that are not production safe.
Exactly. And this applies to basically all of my talks. Let's see if people said anything else, and then I'm going to move on to that. Holy smokes, heck yeah, nice. Yeah, thanks everyone. That's what I wanted to hear. I also say that's awesome to the Playful Machine demo. Yes, awesome, thank you. All right, so let me show you the other thing. By the way, there's this other thingy here with a frame like this. I don't know if it looks better or if it's better full screen. I think this is more classy, but this one you can see more. Yeah, let's go with this one. Okay. Right, so I'm gonna do a bunch of hacky things right now, so hold on to your horses. I'm gonna go to my resource definition, and I'm just gonna copy the machine thing into a web thing, just like that. Very brute force. Let's do things the wrong way. Then I'm going to come here to the controller, and I'm just going to copy my machine controller into my web controller. And you can see even Tmux lost its marbles there. Okay. All right, now let me get out of here, back to Vim. Refresh this, web types. So I'm going to do something here that is very amazing. I'm going to select the whole file, and I'm going to just replace everything that says machine with web. Once again, replace everything that says machine lowercase with web. There we go. And as you can see, this is very sophisticated coding. One important detail is there is no API WebRE in Kubernetes. It's API machinery. And this took me a lot longer than I care to admit to figure out when I first tried this. So let's not forget to fix this. Now let's go to our controller, web controller. Let me delete a bunch of stuff that we're not going to need here. So, am I going to need the context? No, I'm not. I'm going to need a machine? No, I'm going to need just a log line, and everything else can go. So, let me delete everything else that's here. Okay, and this is going to say hello from web controller. Okay, and I don't need this trash here either, because this was for our playful machine in the web controller. All right, but I forgot the replace here, so let's do that as well. Replace machine with web. We go up, and now we replace machine lowercase with web. Let's fix Kubernetes again. Okay, now this should work. Let's see if it compiles. Okay, it compiles. I am shocked. Now let's create a web object and see if that does anything. So I'm going to come back to my config samples, copy my useful machine into a web.yaml, back to Vim, web.yaml, refresh my files. Okay, so the kind here, this is the important part, the kind needs to be web. Let me replace this with, I don't know, web, hello. And I don't have a machine type on the web, I have a web type on the web object, but this doesn't matter because we're not going to use this. So I'm just going to say here, I don't know, what should we say here, Peter?
Happy Friday.
Happy Friday. But it's not Friday yet, it's still Thursday. It should be Friday, god damn it. Okay, right, so now we can do kubectl, apply, file, what's the file again, web. Okay. Unable to record, oh yeah, okay, right, I forgot something. So let's do that. First, I need to go to my main.go, and I need to basically register this other controller because I'm doing things the hacky way. Qbuilder is not going to do this for me. So I basically need all of this stuff on my main file, and I need to replace machine with web. Okay, and there's one more thing I need to do, which is, let me remember this. So go source dex. I think I need to do make something. I don't know which one, so I'm just going to make all the things. So make generate, make manifests, make install. One of these is going to work, I'm sure. I don't know which one, but I mean, I don't care. Now I'm going to go to config crd basis, and now I have web crd, and I need to run this one by hand because I'm doing it the hacky way, so Qbuilder is not going to do it for me. So Qbuilder apply. Okay, now kubectl get web. Okay, so now the type exists, we just don't have one running yet. So success here. So now let's just get one running. And tmux. Okay, now kubectl get web. There we go. Now we have a web object, a web type, and a web controller. And let's see if the web controller did anything back here in our logs. So we should get hello from web controller at some point from someone, but I don't see it, so something funny has happened here. Nope, that's not what I wanted. Web controller. It's not here, this is weird. Let me try something. Controller. Hello from web controller. Yeah, this should have run. It's weird that it didn't. So let me delete that and do it again, just so I can keep track of the logs. This is so strange. Okay, let's see. Kubectl delete web all. Now I'm concerned. I did something wrong. I don't know what I did wrong, so that's why people advise against live coding, I suppose. So let's see, we have our web stuff here. All right, now we're in debug mode. Peter, say something funny while I'm trying to find the bug.
Oh, man. Well, I just think it's kind of funny that the bug is happening at the very end of your presentation.
I know, it's the worst, right?
I also think that this is like debugging in real time is exactly the kind of gritty software realism people want from a live stream.
Yeah, the thing is, live debugging is so much more fun for the people watching than the people doing it. But yeah, I saw a few Linux Tips friends in the audience, and they saw me do a whole lot of live debugging when I presented at Linux Tips the other day. So I really don't know why this is not working. It should be.
Naomi suggests you just start from the top, right? The whole thing over again.
You know, actually, it would take me like 5 minutes to do it all from the top if I'm not explaining. That's what I did on the Linux Tips session.
Okay, how about this? I'll take questions from the audience while you debug.
Cool.
What questions do you have about Tilt, audience members?
Yeah, it takes like 20 seconds for our video to get to them, so it's gonna take a second for them to reply. I really have no idea what just went wrong here. Which is a bummer, because then I can't do the last part of the thing if I don't fix it. Okay, you know what? Did we have any questions? Let's come to the comments and see if people said anything.
No. Naomi just unhelpfully suggested that you could have had a pre-written finished version as a backup.
I think I have a version somewhere that should run, so I can just show you that for the last thing. Okay, I'm gonna do now the next step that I can do with this thing being buggy. Where's the bug, Peter? I can't believe you were not paying attention, Peter, and you didn't catch the bug.
I'm trying here, Al.
All right, so I'm gonna do the next step, which we can do even with the bug, and then the final step's not gonna work with the bug, so I'm gonna move on to another version of this project that I already had. One question, will the web UI be ahead of the terminal in terms of features? Yes, it will.
Definitely.
Peter, you take this question, and I'm gonna set up for the next step here.
How blunt should I be? We think the web UI is the future, and the terminal UI is not the future. And there's a small number of people that are really wed to the terminal UI, clinging to it with... Are you still talking, Al?
Well, you should be talking, because I'm just copying things around.
Yep. Short story. Don't invest in terminal UI. Do invest in web UI.
Yep, that's what he said. So I'm copying a bunch of stuff here onto Vim, and I'm gonna explain what it is in a second. I'm just gonna finish copying it over first. And that's why I had Peter talking, but he never talks much. Come on, Peter, Jesus. Too late, man. You missed the train now. Now I'm writing code already. Okay, so let me just fix one thing. So I did 3 things here. I added an import that no one cares about. I added this function here, and it was a method, but I don't want it to be a method, so boom, not a method anymore. So what this method does is, this is basically the definition of an object that's going to be created. So basically this and this are the same thing. They're both creating a web object, but one is YAML, the other is Go, YAML, Go. And the difference is here, it's called web hello, and it has a web type. Here it's called whatever the name of the machine is, -web, and we don't have a web type. And so we're calling this function from up here, where we're using this function create or update, so that we can use our machine controller to create a web object. So this is because the idea was that I would create a new machine, a new playful machine. And let me make this bigger again. The idea was that I would create a playful machine, and then the playful machine creates a web thing, and the web thing puts the status of the playful machine on the web. That was the original idea. Now, we're using creator update. That's another function. You can see that it's not one of those r dot something, so it's a bit different. There are a few different things that you need to navigate when coding for Kubernetes stuff. It has a bunch of stuff here. Here's my web object that I'm going to create. And so you can see that this is called create or update. So if there is no resource, it's going to create it. If there is a resource, it's going to update it. And it's going to update it using this function, which, as you can see, does absolutely nothing. So we're not going to... Yeah.
We got one question from Gabrielle Viviani.
Okay. What's the difference of using pointer in receiver argument and the returning one and function declaration? I don't know where... Are you referring to the new web object here? Well, basically, I'm returning a pointer so that I don't have to copy the object over in memory, and I think that's just easier. And also, because creator update does want a pointer. It does not want... Why am I getting an error down there? That error is silly. There's nothing wrong here. Is there something wrong here? No, there's nothing wrong. So my IDE is being silly. IDE, right, it's Vim. So this object should be a pointer. So that's why I'm just returning a pointer there. Oh, wait, you don't have my code on the screen because I'm silly and I have the comments up the whole time. All right, let me do this again. Okay, so the creator update function wants a pointer. So I'm just giving it a pointer. And basically that's the story of why I'm using a pointer here. Generally, we use pointers for these things because then you don't have to copy the whole object, and I think it's just good practice. And there's a bunch of like deep copy and whatever stuff that I don't want to have to learn what it's doing, so we can just avoid it. Anyway, what I was saying before is the update part of this function is not being used because we're using this to update, meaning we're not updating anything. So we're basically either if the object is not there, we create it. If it's there, we do nothing. So what's going to happen now is I'm going to create a playful machine. And if everything works, my machine controller is going to create a web object for me. So let's look at that. Okay, so here I can do kubectl get web and watch. And here I can do kubectl apply file playful. And now you can see that, voila, I created a playful machine and my machine controller created a new web object. So that's cool. That means that even though Peter told us that using one controller to create another resource was really, really hard, we managed to do it. Congrats for us. But unfortunately, I think, let me get back here, we still have a bug where the web controller is not running. And this is so sad because I really wanted to show you the thing, but I cannot for the life of me figure out what I did wrong. So I'm gonna close this project and show you the other one where things are supposedly correct. So let me close tilt here, let me come back here. I have a useless project that I was using as basis. So I'm going to tilt up from this one. And hopefully it's going to work. I don't know if I should have deleted everything from the other one first. I suppose we will find out. But now it needs to download an image from Docker, which takes a while when you're streaming to 10 different places, etc.
I have a question, Al.
Yes.
Well, I just noticed that the colors keep changing on those. On the top right of your screen, what do the colors mean?
On the tilt dashboard.
Yeah.
Yeah, so these are the status of my resources. So whenever you do something wrong, you get an alert here, you get an error, it changes color. So basically you don't have to be hunting for errors manually. Whenever you do something wrong, Tilt tells you what it is and where it came from, and that makes it easy to do things. So here, apparently I did something wrong on my useless machine controller. Congrats to me. Let's see what I did wrong and whether this is going to run. Back off restarting failed container. Okay, you know what? I'm going to... Oops, nope. Here. Okay. I'm going to go back to the one before. Make uninstall. And I'm going to do tilt down. So you can do tilt up to put everything up and tilt down to delete the whole thing. Let me also delete the namespace. Kubectl, delete namespace, dax system. And then I'm going to start it again and let's see if this time it works or if I'm going to have a double bug and then I can't show you the final thing. Okay, so we have yet another tilt dashboard open here. And let me see the comments. Is anyone saying anything? Cheers, Gabriel. Thank you. That's what happens when you wish Happy Friday on a Thursday. Yes, it's all Peter's fault. God damn it, Peter. Okay, now let's come back here. And if this doesn't work right now, I'm just going to show you... Oh, maybe it does work. No, there's an error. Why is there an error? I don't know why there's an error. Oh God, I hate computers. Computers are the worst. Okay, I don't know what's wrong here. So I'm just gonna tell you what is the last thing I was gonna do. And yeah, this is probably not gonna work. It's doing a crash loop back off here. Yeah, I have no idea what's wrong. So I'm just gonna basically tell you what I intended to show you. So how do I do that? Let me close Vim. Wait a minute. It told me I didn't save a file and I ignored it. Let me do one more thing. Aha! Of course it didn't work. Oh God, I want to shoot myself. This is so silly. I can't believe I got caught up on this. Do you hate computers, Peter?
Yep.
Thank you. Okay, now this is saved, so now it's gonna run.
Wait, can you tell us what you changed there?
If it works, I'll tell you. If it doesn't, then I won't. Let's wait and see. Yes. Let's see. Wish me luck, everyone. No, wait. We need to see if the web controller is saying anything. Hello from web controller. Okay, we fixed the bug. We found a bug. 40 minutes later, but we found a bug. Thank you. Right, now let me explain what went wrong. Here on my main.go file, I'm basically registering one type and one method and saying whenever there's something with a machine thing, call this function. And I showed you when I added this part, which is basically doing the same thing. Whenever there's a web something, call the web controller. But the thing is, I put the code here and I forgot to save the file because I'm just that smart. So anyway, now that we figured this out, I can show you the thing I wanted to show you. And the thing I wanted to show you is
Uh-oh, El, we lost your audio.
Yeah, my camera got tired again. That's fine. So here on the web controller, we have this. We're setting up a controller and we're saying this controller works for this resource, for the web resource. But I want to put on the web with my web controller any updates to any machine resource. So let's see how we can make one object monitor an object of a different type. So in the real world, you would use this to monitor your pods or something like that. So let's say your database resource, the pod gets deleted, so you delete the database as well, something like that. So let me show you how to do it. And I'm just going to copy some code again because this code is kind of annoying to understand. So I won't write it by hand. We're just going to see it in action. So I'm going to paste some stuff here, and then I'm going to explain once it's there. Right. So the for function is basically an alias to a very long watch function like this. And what this watch function does is it reads a bunch of requests. It encodes those requests into objects of the type control.request. And if you remember from before, control.request is the type that our reconciler receives. So basically, we're taking a bunch of crazy Kubernetes stuff and turning it into reconciler requests that we already know how to use. Now, instead of only monitoring a web object, I'm going to tell my web controller to also monitor machine objects. So what we want to see here is basically, I'm going to run a playful machine again. It's going to do 100 updates to the status like we saw before with the little finger thingy. And every time a machine object changes, we should get a new hello from web controller, because that means that the web controller is watching my machine objects, and that means that we succeed here. So let's try to do that. I just saved everything, so in theory, Tilt is putting everything up there. Hello from web controller, so we know it's working. Now I'm going to create a playful machine again. And I'm going to put it here just so we can see this once more. So watch kubectl get machine. No resources found. Okay, we don't have any machines running. We're going to kubectl apply file playful. Okay, now we have the thing going towards the lever. And if we stop at any given point here, we're getting like 100 updates a minute here. So now, basically I'm getting hello from machine controller and hello from web controller, and they go in succession like this. It's always how do I get this to stop? Can I? No, well, I'm gonna have to wait for it to finish then. Yeah, so whenever I get whenever a machine changes, I get hello from web controller. So here you can see let me show you here. So all of our logs, they have a message, which is here. And they have the name of the resource that spawns that log. So here we can see that we're getting hello from web controller, but not from a web object. We're getting it from a machine object, so machine playful. And that means that, yes, the web object is watching every change to our machine objects too. And that basically concludes what I wanted to show you. Now, a couple more interesting things to note before we wrap this up. We can see just a second, our creator update function is interesting. So let me here do, oops, no, not this. Create or update. So we can see that most of these updates are unchanged because our update function does nothing. But if we scroll back to the first one, nope, here. No, unchanged. Well, yeah, that says, okay, I'm not, Oh yeah, we did not create any controllers now because the web controller was already there before. But when we create one, it says creator update says created. So that would also appear there. But because we restarted a bunch of times, it's not here anymore. And a final silly little joke. This variable is called oppress, not as a critique to the systemic oppression of capitalism, but just because the return value of this function is called operation result, so oppress. So yeah, let's look at Peter laughing at my joke. All right, so thanks everyone. If you have questions, we're going to give you a couple minutes to ask them. If you'd like to ask something about operators, or something about Qbuilder, or something about Tilt, or if you just want to chat about, I don't know, how your day is going or something, feel free to ask here. And else we're going to wrap up in the next few minutes. So Peter, what do you make of that? You looked really bored most of the time, man.
Well, to be honest, I had a hard time following because my video was 20 seconds behind my audio.
Oh yeah, that's fair. That's fair. That's hard. Okay, we still have 24 people here.
I really liked the dramatic tension. I thought it was well planned of you to create a bug, pretend you didn't know what was causing the bug, and then solve it in a sudden turn.
That is exactly what happened. It was completely planned, man. Troy says, thank you, Al and Peter. This was awesome. I definitely appreciate it. Thanks for coming, Troy. Like I said in the beginning, if you all want to subscribe to dex.dev, we're going to send you an email every time we have new content out, or just subscribe on YouTube and do the thing with the little bell button. I don't know how it works really, but every YouTuber says that, so that you get a notification whenever we have something new out.
You got to be like, smash that subscribe button.
Well, you do it now that you've shown that you know how. Let me make you bigger on the screen, actually.
Yeah.
There you go. There you go.
All right.
Do it.
Thanks, everyone. If you like this comment, don't forget to smash that subscribe button. We tweet, and definitely follow Elle on Instagram and Twitter, and the newsletter that they mentioned.
There you go. We have the thing on the screen so that you can... you did great, man. I'm just following up, and I put the Twitter handle for dex.dev up there, and now it's saying dex.dev, the website, not the Twitter, and in about 7 seconds it's going to change to another one. So let's see. There you go. Also tilt.dev, which is the little, well, not little, but the software tool thingy that we use there, which is not little at all. I shouldn't have called it little. What if my boss thinks I called Tilt little? I'm gonna get fired. All right, let's go back to the comments, see if there's anything else. Looks like that's it for now. So thanks everyone for joining. Do what Peter says, smash the smashy thingy. Yeah, for sure. Does Peter have a Twitter link? No, because
I haven't tweeted in 2 years.
Right. I was going to say a very terrible joke, but that was a better reply than what I was going to say. All right, so thanks again, everyone. Smash the smashy thing, and see you next time. Thanks a lot for joining, and bye-bye. And have a great Friday, don't forget. Not Thursday. Thursday's going to be full of bugs, but have a great Friday.